So we're looking at exponential notation, or raising something to a power. The guy who came up with this is actually Rene Descartes, who gave us, I think, therefore I am. He was a French philosopher, and he absolutely did. He came up with this, and something which was even more revolutionary.
So exponential, what is it?
Exponential notation.
So it's not a rock band.
It's not a rock band.
No.
It's a form of mathematical notation. To understand this, you're going to need to know about adding negative numbers, multiplication, and fractions.
Okay, we've got all that so far.
Got all that so far?
Good to go.
Basic idea is raising something to the power of putting that little superscript 2, call it 2 to the power of 2 is the same as 2 multiplied by 2. 2 times. So there's 2, and then we multiply by 2. If it's raised to the power of 2, we call it squared, because if you draw it up like that, it looks like a square.
Yeah.
If it's raised to the power of 3, it means we'll multiply them together 3 times, and we call that cubed, because it's kind of like a 3. So 2 cubed is going to be 8, 3 by 3 by 3.
Yep, this is emerging from the primary school sludge. Very good.
Coming back, 2 to the 4th, 2 multiplied by itself 4 times. And just in terms of terminology, we call that 2 the base. We call the 4 the exponent or the index. Sometimes actually the logarithm. Don't need to worry about that yet, or why that's a logarithm, but later that becomes relevant. But we don't call the 4 the power. We say the whole thing is.
Oh, is that right? So I think I had it in my head that the little number was the power.
No, we call the whole thing 2 to the power of 4. But the little bit on the top isn't the power. Just technically. If you want to be technical.
Yeah, let's be technical.
Yeah. Now, the great Einstein, Albert Einstein, is famous for the theory of relativity, which is not why I really like him, because I don't understand the theory of relativity. What I like about him is he came up with great quotes.
He certainly did, didn't he?
And one of my favourite quotes is, never memorise anything you can look up.
Oh, I love that one.
Yeah. So I'm going to show you a whole lot of stuff here, and it might seem a bit overwhelming, but the thing is, you're not going to have to memorise any of these things. We're going to go through them one at a time. I don't want you to have to try and keep it in your head.
Okay.
I want to show you that there is a proper place, that there are actually sensible places where all this came from, and you can look it up here if you need to, or to give you the tools you can, if you come to it, I haven't seen that for a while, how does that work? So you can work it out from first principles. So I won't read them out to you now, I'll go through them one at a time and answer the big question, why all these work? Because here at How to Love Statistics, we're all about the why do things happen like that. So the first rule is to multiply two bases, two of the same base raised to a power. You multiply the index. You add the indices, or indices is plural of indexes of index.
Oh, okay. So the indices are those little number.
The little number.
Yeah.
So you add 2 to the 4th times 2 to the 3rd. Well, what we're looking at there is 2 to the 4th is 2 multiplied by itself 4 times.
Yeah.
And we're multiplying all that by 2 multiplied by itself 3 times.
Yeah.
So altogether, the brackets don't matter. We've multiplied 2 by itself 7 times, which is actually the same thing as just adding 4 plus 3.
Yes.
Which is
2
to the 7th, which we would work out if we wanted to. So to multiply, you add the indices, and to divide, you subtract the indices. So 2 to the 4th divided by 2 to the 3rd, well, that's 2 multiplied by itself 4 times, divided by 2 multiplied by itself 3 times. Then when we looked at fractions, we said you can cancel out. The 3 2's on the bottom will cancel out with 3 of those 2's on the top.
Yes, I remember that.
Which is really just the same as subtracting 3 from the power on the top. So that leaves us with 2, that's 2 to the 4 minus 3, which is 2 to the 1st. So to divide, you subtract the indices. Now anything raised to the power of 1 equals itself.
Anything raised to the power of 1 is equal to itself.
Is equal to itself.
Because is it the number multiplied by?
But yeah, just put there one time, not multiplied by.
Okay.
Yeah, exactly right. But another way to think about that.
Yeah.
So I've got 2 multiplied by itself 5 times, 2 to the 5th, and we've said that. Well, so 5 is 4 plus 1.
Yeah.
And we've said that if you multiply, or if you add the indices, it's the same as multiplying 2 to the 4th times 2 to the 1st. which is going to be that, and those first 4 are 2 to the 4th. And so all that remains is multiplying both sides by 2. So 2 to the 1st has to equal 2. It's the only way it can work.
Yeah.
So anything...
The only reason we put the little 1 is because we're working in this type of maths. So you need to designate that that's 2 to the 1.
So sometimes you do, but when you see 2, you can go, well, that's actually 2 to the 1. When you see 2 to the 1, it's just the same as 2.
2
it doesn't.
And 2 to the 1, just the same person with a slightly different name.
Exactly right. But same individual lying under that.
Yeah, okay.
Perfect. Love the way you see these things. Now, anything raised to the power of 0, this isn't quite so intuitive, that equals 1.
Oh yeah, this one's messed with my head in the past, so this will be really interesting.
Okay. So again, we've got 2 multiplied by itself 5 times, and that's the same as multiplying itself 5 plus 0 times.
Yeah, okay.
And we've already said that's going to be the same as 2 times 5 times 2 to the 0, because we add the indices is the same as multiplying the base.
Yeah, right, with you there.
Each time. So that means 2 to the 0 can only equal 1, because multiplying by 2 to the 0 can't have changed anything. There's quite a number of other reasons it has to work that way.
Okay.
You find all the time that's the only way it can work, even though it's not quite intuitive. So anything, or it's not obviously intuitive when you look at it, but the more you go, that's the only way it can happen.
Is this going to be something that will make more sense for the Y later? Because part of me is going, what is the point of 2 to the 0 if it's 1? Because you're just saying 2 to the 5th multiplied by 1, which is just 2 to the 5th.
It makes a lot of sense when we start using these in formula and so on. This is useful building blocks you need
These
to have.
building blocks idea.
And again, you not going to have to remember it, but in fact, to learn statistics, you're not going to have to do the formula. You're just going to have to follow along with what someone else has done. So if you can see that they've done that and go, okay, I see where they're coming from there. They said that was 2 to the 0, that's the 1. I'm there now.
Point, right? Is it so we can understand what's going behind it instead of just being bamboozled by someone.
Exactly right. Around. Yeah, I understand with that, or I disagree with them, whichever you like.
Okay, cool.
Now, to raise something to a power and then raise it to another power, you multiply the indices.
Okay.
This is commutative. So 2 to the 3rd, all raised to the power of 2, is really the same as 2 multiplied by itself 3, multiplied by itself again, which is the same as, those brackets don't matter, 2 multiplied by itself 6 times, which is the same as 2 to the 6, which is 2 times 3, which is the same as 2 multiplied by 3 multiplied by 2, which is the same as that, which is the same as that. So you can put those in either order and you just multiply them together.
Okay. I just had another glimpse this time from high school, John. I had a maths teacher who used to always say mathematics is beautiful, and kind of until this moment I had no idea what he was talking about. But there's a certain beauty in that.
It kind of is, a beautiful convenience that works that way.
In a way it kind of can flip around different ways. And all.
Yeah, because then you really are saying 2 completely different things there.
Yeah.
And to say that they're the same thing is kind of neat, isn't it? You really are saying quite different things. You're saying you're saying here that 8 times 8 is the same as 4 cubed, which you wouldn't necessarily assume that had to be the case. But that's,
and that's kind of, for me anyway, that's where we'll break through as we've been talking together.
Excellent. This is where it gets particularly unintuitive, but it does have to work this way. Raising to the power of a fraction is the same thing as taking the root. So what taking the root means is doing the reverse of raising to a power.
Okay.
So if 2 squared is 4, then the square root, or the second root of 4, is going to be 2.
So they're kind of reversing of each other.
They're reversing each other.
Yeah. Okay.
Yeah. So why it has to work that way, if we look at, say, 2 to the 3rd, all raised to the power of 1/3, we've already just seen that if you, that's the same as just multiplying 3 by 1/3.
Yeah.
And if we multiply 3 by 1/3, we get we get 1, because 3 lots of a third, or a third of 3 is going to be 1. That's 2 to the first. So that's another way of saying, so 2 to the third is 8. So 8 raised to the power of 1/3 has to equal 2, which is kind of the opposite of raising 8, which is what we started with in the first place.
Do you know what's exciting?
What's exciting?
I'm starting to see what looks like really complicated formulas, and I'm seeing that once I'm getting the hang of it, although it looks on first flush as a complicated formula, it actually can make sense, which is exciting. I just thought I'd share that.
I am very excited that you find that exciting.
Yes.
So that's kind of
It's
the
like
thing with
light coming
a lot of this stuff. It looks intimidating.
Yeah, exactly.
That's logical. That's fine.
No, that's great.
Exactly. And we can also write that as the cubed root of 8, which again means, well, what is it that you would cube to get 8?
Yeah,
And the answer to that would be 2. So raising it, so that's not always obvious that you would, why would you do it? But that's why it has to work that way. So raising something to a fraction means taking that root of something. And also not immediately obvious, raising something to a negative power is the same as raising the reciprocal of a power. So
say that again?
Yeah, raising something to a negative power is the same as raising the reciprocal to the power. So
Okay.
reciprocal is when you turn the numerator and denominator upside down.
Yep. Right.
Did that with fractions. So why that works? So 2 by 3 multiplied by 3, 2 to the minus 3. We've said you can add the indices. So that's 2 to the 3 plus minus 3, which is the same thing as 2 to the 3 minus 3. If you're not sure why that is, we cover that in the book How to Love Statistics. 2 plus minus 3 is the same as just minus 3. 3 minus 3 is 0. We've already said anything raised to the power of 0 is 1. So 2 cubed times 2 to the minus 3 equals 1. Therefore, 2 cubed is 8, or 2 to the third power is 8. If we multiply that by 2 to the minus 3 and get 1, all it can be is the reciprocal of 8. It has to be, in other words, you can see you're not quite convinced there.
No, just keep going.
I'll keep going. So 8 times 2 to the minus 3 is the same as 8 on 1 times 1 on 2 to the third.
Okay, that's
so
the reciprocal.
Yeah.
Okay, I just needed to see that.
Had to see that?
Yep.
Got it. So that's multiply 2 fractions, we just multiply the numerators and denominators. So that's 8 times 1 over 1 times 2 to the third, which is just 8 on 2 to the third. 8 on 8. It's equal to 1.
Okay. We're getting there, John. Well, I'm getting there, John.
That's the rules of indices. And like
Brilliant.
I say, you don't have to memorise those. You can just come and look them up, or just write it out a few times to remind yourself of how it works and why it works that way.
Thanks.
Thank you for watching.